Hello everyone, my name is Fayaz Khan Sahil and today we're gonna learn about atomic structure. Let's begin. Let's look at our learning objective. Our learning objective would be describe the structure of an atom. We'll learn about relative charges of proton, neutron, electron. We will also learn about proton number, mass number, and also I will show you how to draw electronic configuration of an element. Let's start by learning the definition of an atom. All substances are made up of tiny particles of matter called atoms, which are the building blocks of all matter. So all matters are basically made up of atoms. Let me give you guys an example. For example, this is a sodium metal. Okay? If you zoom out the sodium metal, you will see tiny, very tiny. Honestly speaking, you cannot see an atom with a compound microscope or light microscope. Okay, so if you see the structure, you will find made up of tiny atoms of sodium. So as you can see, this is the building block of a whole metal. Now let's go through what is the actual structure of an atom. So atom consists of central nucleus and electron. Okay, if you look at the nucleus, it is consist of proton and electron, and there is one another subatomic particle. Do you guys know what is it? It is neutron. As you can see, proton is positively charged and electron is negatively charged. So you might think, sir, what is the function of neutron then? This is the most interesting part I find in an atom, right? Have you seen the proton is positively charged, right? If two proton get very close to one another, they will repel one another, right? Two same charges repel one another. So there is always neutron which separate two positive charges to come close to one another. So that is the main function of neutron. Now let's look at electronic shell. Electron moves very fast around the nucleus in an orbital path called shells. This line you are seeing is basically an imaginary line. So electron actually follow this path. And the structure we actually see in the books, you see a one-dimensional structure, right? Like this way. But it is actually three-dimensional. As you can see, it not only move in this path, it also move along this path, right? It form a cloud actually. If you see atom, it's actually a cloud instead of this. Now let's look at their relative charges and relative masses. So proton is positively charged. What about neutron? What charge does it hold? That's correct. It's neutral. I don't know if you guys say that or not. I just said it. So electron is negatively charged. Now let's look at the relative masses. Proton is 1. Neutron is 1. However, electron is 1 by 1836 the mass of a proton or neutron. Mass of a proton or neutron. Okay, sorry for my handwriting. I'm using this graphics pad not for a while, just I have used it at least 10 times I guess, that's it, but I'm not used to it, so stay with me. Now let's look at proton number. This is very interesting. Proton number are also called atomic number. Okay, it is denoted by the symbol Z. If you see the Z, suppose a element A, if you see the Z above, it always means atomic number. Okay, for example, let me give you guys an example. For example, the hydrogen atom has one proton, so the atomic number of hydrogen is 1. So, however, the interesting part about atomic number is that the number of proton is equal to the number of neutron in a neutral atom. What is a neutral atom? Neutral atom mean it didn't form ion. For example, it didn't gain or lose electron. For example, Na plus. It's not a neutral atom. As you can see, there is a charge, right? For example, Cl minus, there is a charge. These twos are not neutral atom. However, sodium atom, only sodium atom, has equal number of proton and electron. Let's look at example. Now we have carbon, okay? Carbon has, the atomic number of carbon is 6. Sorry, let me erase this thing up. By the way, from where you guys are from, please write that down in the comment section. And I'm really new to the YouTube thing, so keep some patience, and I hope all of you guys get A stars in your exam. Now let's look at atomic number. Atomic number of carbon is 6. Atomic number also denoted by Z. But carbon has also 6 electron. So proton number and electron number are equal in a neutral atom. The condition is that they are not in their ionic stage, or they are not sharing its electron. Okay, now let's look at mass number. Mass number are also called nucleon number. It is a total number of proton and neutron in the nucleus. So if you can see the formula, this is a mass number. So how you calculate mass number? It is a number of proton plus number of neutron. Let's solve a math. I will give you an easy one. These maths are very easy. So given this is a sodium atom, so given proton number 11, mass number 23, find the neutron number. So how would you find this thing? First, let's write the formula. Mass number equals to proton number plus neutron number. As you can see, the proton number, mass number is given as 23. 23 equals to, then we have proton number which is also given. Now we have to find the neutron number. Let's denote it by N. Okay, so what should be your answer? If your answer is 12, it's correct. How would you find this thing? Like you just shifted the 11 over there. 23 minus 11 is 12. Now we're gonna learn about electronic configuration. Electronic configuration is the way in which electrons are arranged in shell around the nucleus. Sounds complicated, right? But it's very easy. They wouldn't ask you for a definition of electronic configuration in O levels, but it's okay to learn it, just understand it. Let me explain you simply. Electronic configuration is simply how the electrons are arranged in a shell. This is an atomic shell, this is a two-dimensional, that's why you can see this way. So how electrons are arranged? In the first shell, you will always have 2 electrons. For example, here is 2 electron. In the second shell, 8 electron. You will drop this by this way, okay? Okay, and third shell, it will also have 8 electron. Okay, now you got it. But don't write the configuration of second shell like this way. For example, this is the first shell, the second shell. Don't write one in this way, one in this way, this. Don't write in this way. You will always should write it in pairs. As you can see, these are pairs, right? Write that thing in pairs. Now let's solve some examples so that you guys can really understand what is happening right now. Let's look at the potassium one. Potassium has 19 proton. This is a proton number, right? This is a mass number which is denoted by A. So potassium has 19 proton, which also mean it has 19 electron. Let's draw the shells. Let's use this one. Now let's use the yellow one. Let's draw the shells. So we have 19 electron, right? So in the first shell we'll have 2 electron, right? 1, 2. Then in the second shell, how many electrons should we get? 8, right? Let's write 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many electron it's subtracted? 8 plus 2, 10. 10 already done. How many we need to solve? 19. Let's draw a third shell. Sorry, the drawing isn't that good. Stay with me. Now we'll also have add 8 electron. 8 electron, 8 electron. So how many total we have? 18. 2 plus 8, 10. 10 plus 8, 18. Now in the outer shell, now we need to place one more electron. So one more electron would be going this direction. So this is how you draw electronic configuration. But don't draw circle like me. It's really bad. I used to be good. I am good, but I don't know how to draw that in graphics pad. So now let's solve another question about sodium. Sodium has 11 electron because proton number is 11. Now let's solve it up. In the first shell we'll have 2 electron. In the second shell we will have 8 electron. So 2 plus 8, 10. So how many electron left? 1. So in the third shell, we'll have one more electron. This is how you draw the electronic configuration. Today we are up to this. See you guys on the next class. Please do subscribe to my channel. See you guys on the next class. Bye bye.